All right, let's begin. To our Twitch viewers, thanks for hanging out with us this Sunday afternoon. We really appreciate it. To our YouTube viewers, thanks for checking us out and sticking with this series. This will mark episode 74 of this series. I'm hoping that I'm meeting everybody's expectations of what I laid out. I know it's a little helter-skelter, but unfortunately, that's kind of the way development work goes. It's not perfect. There's always a lot to do. Things go wrong. Things happen. And you always have to account for things that just happen. It's just like life. Things happen that sometimes you can't prepare for. You can do the best you can, but, when parts break down, things don't work exactly as intended. That's what happens. And sometimes doing new projects and things is chaotic. No matter how big your organization is, even larger companies suffer chaotic projects, especially when something throws a wrench into the works. That's just the way it goes. So where we left off is we started coding the driver for the temperature sensor. And I'm pretty sure we've got it working. The decimal place was just out by 1. I kind of updated that. So let's go over here. Kind of updated it to divide it by 100 instead of 10. And that put the decimal place, more aligned. But there's no, decimal point. So let's see if we can figure out how to fix this rolling average. So what we could do is kind of change it to where it does the temperature conversion and then it does a rolling average on the temperatures themselves rather than the actual ADC millivolts. Because that's basically what we're doing is we're taking this. So let's make sure that we've got this all right real quick. Because it's fine. Again, we're not seeking perfection. So we have our buffer. Let's see here. We need to subtract the value being overwritten. All right. Index plus 1% window size, yeah. Okay, it looks like it should be working after updating some of the code. So it looks like, it looks like we are getting it. And I finally found the batteries, the battery for my so let's over here. So I found the battery for this guy, the IR temperature sensor. And then I also have got my multimeter with a thermocouple. So let's see here. The contact list says it's reading about 20 degrees Celsius by the chip, or on the chip itself, 20, 21. My multimeter says it's about 24 degrees Celsius, 23, 24. And the temperature sensor says it's around 25 degrees Celsius. Decimal place doesn't really matter as long as it's reading. So what we're going to do is we're going to kind of warm this little guy up with my little hot air tool. Why do you have to turn off? All right. All right. So, okay, so it's definitely warming up. Like 40 degrees, 36 degrees Celsius, 51 degrees Celsius according to the thermocouple. Okay, so I think we've got a problem with our logic in our firmware because the average isn't okay. Yeah, so the temperature isn't changing. So we've got a problem in our logic in the firmware. All right. So let's first temperature equals. Let's just do voltage value. Let's see if this will change. Because our rolling average logic may be broken. All right. So we're gonna flash this little puppy. Because if it's our rolling logic, we'll work on fixing it. There might be something I'm doing wrong. Okay. Okay, there's some weirdness there. Yeah, it's not going above 25, so something in the ADC logic is broken. Let's see what could be going on here. Oh. Let's go and look at the actual example that where I pulled this from. Do I have the wrong ADC unit? ADC. Make sure I've got the right unit because that's what maps to the GPIO pin. So we even need to... All right, ADC unit. Okay, here's the ADC unit. Okay, so it's ADC. Okay, well, what's the GPIO? GPIO 2. It's ADC 2 channel 2. Okay, ADC unit 2 channel 2. Okay, so we're on the right GPIO pin. Well, you know what? When in doubt, basic modules, temp test. Let's see here. Let's open that up in code. All right. So we should see the voltage value changing here. COM 21. All right. When in doubt, let's go to code that used to work. All right. All right. So, buddy, load 21. We'll load that if we have to, because we might be able to get the printfs on the RS-45, but I don't think so. Because once we can get it reading the temperature right and reporting it properly, then we can work on incorporating all that into the monitor and controlling the fan and everything. Because all this driver is going to do is just read the ADC pin and convert it over. Now the thing is this driver will probably have to really take some time and expand it out to be able to say, well, it's on GPIO 2. That way the system can see that and basically choose the right ports. We might have to do some changes to this. Okay, I didn't really see this, and it was my mistake. We might have to do some more changes to the board. So, so I found, Copilot kind of searched those. I have to double check, but if that's the case, so if we go here, here's ADC 1, ADC 2. That's where we are. ADC pins cannot be used for analog reads while Wi-Fi is active. So in other words, if we want to be able to have Wi-Fi in this, or if somebody else does, we're going to have to, we're going to have to fix that. So we're going to have to basically kind of swap two pins. Great. All right, well, it's another minor change, but that's fine. We can deal with it. Okay. I don't think this will do anything for this guy. Yeah, it won't print up in here, so I have to start this guy. 752, 54, 6. All right, so I'm heating it up. And it's climbing. The ADC is climbing. So we're reading through this example. So, fine, we're reading through the sample. We're actually getting the ADC value. All right, so we know the pin's working. All right, so what have I done wrong? Okay. All right. Let's get these guys moved. Okay, let's get those back up here. Oh, this should change. All right. ADC. Which value? Let's get these guys. All right. All right. So we're basically. All right. Let's make sure here we have prototypes. Here's the init that clears the buffer. Here it initializes the ADC unit. ADC raw. Voltage. Right. Okay, ADC raw. Let's not do this. Let's not do any weird conversions. Let's just. Let's see if we can get that to change, because it could be just this logic is broken. Maybe I'm just not paying attention. All right. Okay. Okay. All right. So it's kind of like it's maxed out. Let's try to figure out what my logic is doing. There's only minor fluctuations and something just feels wrong. All right. So what did I mess up? I probably changed some stuff. EC chant, EC raw. ADC Kelly, ADC roll, and voltage value. So something must be wrong here. All right. AC1 handle and handle null. So we're going here. Channel config. Channel 2. Honestly, stop that. What am I missing? Ugh. Hmm. Okay, so that voltage. 3050. So, oh, so, so let's see. We're at 12 bits to 12. So 4096 should be the maximum ADC value. Let's see here. Oh, let's see what the ADC raw. what the raw ADC value is. Oh. All right, enable. So this will just be the raw ADC value. So it's almost near maximum deflection. So I have something configured wrong. Is that the right GPIO? Make sure we're mapped right. Well, it'd have to be because the example code that I was using, channel 2 on unit 2. So that would be GPIO. So that'd be it should be the same GPIO code. So something in here I broke. This fine. Okay, so let's go step by step. ADC unit 2, one-shot unit, big 1. Config 1, ADC 1 handle. Okay. Big channel. Config. All right. ADC. ADC Kali line fitting. Kali config. That handle. And we're gonna create a task. Interrupt ISR context. You know what? Let's complicate matters a little bit because no. Let's just grab this. Make sure we're actually still looping in the task. Temp task looping. Because what I'm afraid is somehow it's it's returning out of the task because of the one shot. And then I can just have it send the data without having a. So it should, okay, we're not exiting the task. That's good. Just keep that there. All right. So we're definitely looping in the task. So something I might have set up wrong. One shot read. EDC one handle. Calibration handle. Should have been no. Let's see if that makes it mad. Maybe the null is upsetting it somehow. But then again, why does it work for the independent example but not in here? I don't. I didn't expect to be stuck multiple days on this. Okay. Yeah. So that's the 80 C value. What is wrong? All right. What did I do wrong? It's converted. Oh. So we are in the task. All right. What do I want to do? Response. And oh. Right, it's probably gonna puke its guts out. Oh. What is wrong with this thing? Why is the ADC value so dang high? Because we were like at like 700 or something before. All right, what did I do wrong? Now it's going to take a little bit of time to untangle my cluster here. Knit. Right? So let's do something crazy. Let's grab this while loop. This should call this and then start doing the loop. Let's not make it a task. Maybe some reason it doesn't like being a task. I don't know. I don't know. Let's see what it does. Okay, so that wasn't the problem. All right. Oh, why are you broken? Why are you broken? I was hoping we could move on, get to some stuff, but if we're not going to read the right temperature values, it's never going to work. So we know we're in the task. It's not exiting because the RS-45 data shows it's looping. Okay. Okay. Wrong. Voltage. Don't care about this stuff right now. Well, my ADC value. Let's, okay. You, all right. Build. Oh, it's a D percent. D. All right. One-shot read. ADC roll. Well, that's defined up here. ADC roll is defined up here. Channel 2. One handle. All right, this is driving me nuts. What in the world? It's broken. One equals ADC unit 2. All right, fine. Ramps have errors. Unless another peripheral in here is interfering. All right, let's think about that. Okay. Let's not init the fan. The columns are you. Okay, let's not init that. All right, let's not initialize everything. Unless it can't update because this task is taking all the time. Kind of like how before I do anything else too dumb, all right, if, let's give this guy a small delay. Because this main task could be stealing all the cycle time. Let's try it. Because if one of these other auxiliary tasks was breaking this, then it's possible that that is breaking the other tasks. So, I don't know. No. All right. So let's shut off some of these other systems and see what could be intersecting with this or interfering with this. So let's shut off the fan. Let's shut off everything except for the UART. And if it does work, we'll bring them up one by one. All right, where are you? What are you mad at? What? Hmm. Mm. No. So I have to turn off the UARTs too? Oh, come on. Are you kidding me? Why? Why? UART consoles. Are you kidding me? Probably gonna fail still. Oh my god. Yeah. So what we're gonna have to do. All right. Let's see if that'll at least build. Oh. Yeah. So this guy can't use this. We'll just have to use basically printfs and monitor COM21. All right, so ADC value. Nope. What did I do? All right. That should be what? Should be poly. Okay, it's gonna fail on that. It's just gonna be a U integer build. That'll be 21, so it'll print. Right. Putty. We should be able to open it and reset. 700. Okay. We're getting same voltage values. Okay. Heating it up is increasing the voltage value. Okay, all right. So it is one of the subsystems interfering with this ADC. All right. So that's a positive. All right. So let's figure out what one of these subsystems that we're bringing up could be interfering with it. I don't think it's the fan. But let's... Because what we might have to do is figure out... we may have to actually do the redesign before we can really push on further with this. All right, because one of these, like I said, one of the, that should do it. Resetting it? No. You know, okay. I want to be able to like disconnect without closing. I mean, I have to close it, and then I have to restart the stupid session. I mean, I guess I could turn off the, I mean, I could just monitor it, derp. Okay, so we have a low voltage value. The temperature's going up. All right. So it's not the fan driver that's causing it, which I guess is a good thing. Yeah, so what we'll do, we'll just monitor it from in here. We'll just use the monitor in here. So it's not the fan. Let's see, it's the NVS. So there's a problem with the UARTs is I hope it's not the UARTs, because it could be a timing thing. All right, let's flash this puppy. Did it not? Oh. Goes. Yeah, we'll just monitor it from down here. Monitor. Reset. Okay, so yeah, we've got the value. Oh, I'm hoping it's not UART stuff. Okay, it's definitely reading. It's definitely getting a temperature value. Okay. Let's see about the status in knit. Hopefully it doesn't make calls with yours 45. Oh. Okay. Okay, we're going to flash you. I don't think it'd be the status. If anything, it's going to be one of the gonna monitor the device. 700. The heater gun again. Oh yeah. Okay. All right. Now we'll see if the motor system is causing it. It shouldn't. Flash ya. Ugh. I have a feeling that the UARTs are interacting with the... Oh. Wait a minute here. That is the... Okay. So it's the driver initialization. So let's go to the driver. All right. So okay, well, all right, let's see here. Okay, ESP32, 32, ADC unit 2. Okay. 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 All right. Does the... Okay. Okay. PWM. Does PWM. I think because they might be sharing... Let's see here. Let's go... Right. USB 32. Let's see. So it's definitely the PWM causing a problem. Channel configuration. Wonder if we could set a different channel for it. Let's see, channel configuration. Let's see what this does. That's a lot of help. Wonder if we can change the LED-C channel drivers. Wonder if we can change it to use a different LED-C channel. We might have to figure out how to write this differently, but let's see if we can. I mean, I don't know if that makes a difference. Oh, maybe the timer needs to be changed. Where's that enabled? Timer is 0. Oh. Let's change it to timer 1. Let's see if we compile. Task, I don't care. All right, let's flash it over. I wonder if the timers are just interrupt. Maybe that's all it is. Oh, 121. Why is this? Oh, derp. It's supposed to be monitoring in here. No. How many? Let's go to timer 3. Oh. So I might have to get one of the breakout boards and try different ADC channels to see which works with this. Oh boy, it's gonna be a lot of fun. Okay, now let's try. One channel. Timer 3. Yeah, I think that's what we're going to have to do. All right. It's definitely the stepper driver. All right, let's see here. Let's see timer. ABC. Okay. Two. All right. All right. Okay. All right. So there might actually be an issue with lead C and ADC. Maybe ADC. Lead C and Wi-Fi. All right. Well, I think somehow they're overlapping and interfering with each other. So I might have to. Oh, great! This is gonna be a lot of fun. So I think that's what I have to do. I'm just gonna have to. We're gonna have to. Experiment on a dev board. See what ADC, because I have to change it anyway, because if we want to use Wi-Fi and that at the same time, that will need to be changed. Oh, headaches. All right. Well, that's what we'll probably do in the next video stream is we'll just kind of chunk through this code and play around on an ESP32 dev board and see if we can get everything playing nicely together. So with this, the motor drives. So it's not like it's, so the LADC is just causing the ADC not to read properly. And I don't think there's anything we can do in here because unit 2 and the channel, unit 2 and the channel, that's what defines your your GPIO pin. So that's what we'll do in the next video. The next stream is we're going to troubleshoot this. And I think what we're going to have to do then is just find a configuration that works and do some updates to the PCB and do the version 2 spin a little sooner than I anticipated because this we can't really do a whole lot without actually running the motor and doing all this at the same time. We need the ADC to work. This was definitely a problem that was unforeseen because the documentation is not clear. It only mentioned it down the road about Wi-Fi interference, and I should have looked for that. So everything's pointing to basically unit 1. So that's what we're gonna have to do. So ADC 1, we're have to. I mean, it's fine because there's several pins that we could use, and just swapping out because it's an input. Like we could use GPIO 36 for the ADC input, and it would be fine. Or GPIO 38, 39, and just swap with another function. Swap with like maybe a limit switch or something. And that won't have that big of a break because we'll basically be swapping 2 inputs. But we'll have to, like I said, we'll have to do some testing on the dev board to make sure we get it right before we commit every change to the dev board. Or change everything, commit all the changes to the next revision. All right, well, sadness, but this is the way it goes. This is how it happens. It's rather unfortunate, but you know, at the end of the day, that's just the way this goes. So I appreciate you hanging out with me this afternoon, and we will catch you in the next video. It may not actually be tomorrow. I've got, like I said, work is getting more busy. More things are actually starting to pick up at work, which is quite good for me. So the streaming and video recording may be dropped down to weekends. It's unfortunate sadness, but my real job comes first. So catch y'all later and have a nice rest of your afternoon.